Thousands of years ago, there was no civilization, no cities, no laws, no language, no written history. There was just one small, fragile creature standing on the open grasslands of Africa, outnumbered, outmatched, and completely exposed. No claws, no fangs, no natural armor. And yet somehow that creature survived. Not just survived, it conquered the entire planet. This is the story of how that happened. From the very first spark of human life, all the way through evolution, migration, and the slow, messy, remarkable rise of our species. And the deeper you look into it, the more you realize this story isn't just about the past. It's about why you think the way you think, why you fear what you fear, and why humanity is the way it is today. So let's go back, way back. About 7 million years ago, in the forests of Central Africa, something was changing. A group of primates, not quite apes and not quite human, began spending more time on the ground. The trees were still home, but the ground was calling. And slowly, over millions of years, something remarkable began to happen. These creatures started walking upright. Now that sounds simple, but it wasn't. Walking on two legs changed everything. It freed the hands, it raised the eyes above the tall grass. It allowed early hominins to travel farther, carry food, use tools, and see threats from a distance. It was one of the most consequential biological shifts in the history of life on Earth. And it all started with a small group of creatures choosing, generation by generation, to stand up. The earliest of these upright walkers were the Australopithecines, species like Australopithecus afarensis. The famous Lucy, discovered in Ethiopia in 1974, walked on two legs around 3.5 million years ago. Their brains were still small, roughly the size of a chimpanzee's. Their faces were still ape-like, with heavy brow ridges and protruding jaws, but they were walking upright, and that one difference would change the entire trajectory of life on this planet. But here's where it gets interesting. Walking upright came with a cost, a serious one. Two-legged locomotion is actually less efficient than moving on four limbs. Early hominins got tired faster, were slower than most predators, and were physically weaker than almost every large animal around them. So why did evolution push in this direction? The answer is probably the same reason most human adaptations exist. It was worth it in the long run. Freed hands meant the ability to carry infants, gather food more efficiently, and eventually to make tools. And tools changed everything. About 2.5 million years ago, a new chapter began. A genus called Homo appeared in the fossil record. These early humans, species like Homo habilis, had slightly larger brains than their Australopithecine ancestors, and crucially, they were using stone tools. Simple flakes of rock sharpened by striking one stone against another. Doesn't sound like much, but this was the beginning of technology. Think about what a sharp stone actually means. It means you can cut through animal hide without teeth strong enough to tear it. It means you can process food faster. It means you can defend yourself, carve wood, scrape bone. A sharp stone is an extension of the human body, and it was the first sign that our ancestors were beginning to reshape the world around them rather than simply adapting to it. And then roughly 2 million years ago came a species that would spread across the entire old world. Homo erectus, taller, stronger, more intelligent. Homo erectus was the first hominin to leave Africa, spreading across Asia and into Europe. They made more sophisticated tools. The hand axe, a carefully shaped bifacial stone that was far more versatile than anything before it. And most importantly, they almost certainly controlled fire. Just think about what that meant: warmth in cold climates, light in the darkness. A way to cook food, which made calories more accessible, reduced the energy needed for digestion, and may have directly contributed to the expansion of the brain. Fire kept predators away at night. It brought the group together, and around that fire, early humans began doing something that no other animal had ever done at the same level. They started communicating, sharing, teaching. The fire was more than a tool, it was a social technology, the first gathering place. But here's where the story gets complicated. Because for millions of years, the Earth wasn't home to just one kind of human, it was home to many. Homo erectus was out there in Asia. The Neanderthals were in Europe and Western Asia, stocky, cold-adapted, intelligent hunters with brains as large as ours. The Denisovans, and possibly across a wide swath of Asia. And in Africa, the lineage that would eventually become us. Homo sapiens, was slowly, gradually taking shape. The fossil record puts the emergence of anatomically modern humans at around 300,000 years ago in Africa. But anatomically modern doesn't mean behaviorally modern. These early Homo sapiens looked like us, but they didn't necessarily act like us, not yet. What happened next, and why, is one of the biggest debates in all of paleoanthropology. Around 70,000 years ago, something shifted. There's evidence of a sudden explosion in behavioral complexity. New types of tools, art, personal ornamentation, long-distance trade networks, more complex use of language. Some researchers call this the cognitive revolution. Others argue it was a more gradual development that simply appears sudden in the fossil record. But whatever the cause, by this point, Homo sapiens was doing things no other species on Earth had ever done. And then they left Africa. This is the out-of-Africa migration, the moment when a relatively small group of modern humans walked out of Northeast Africa, across the Sinai Peninsula, and into a world already occupied by other hominins. Neanderthals were in Europe, Denisovans were in Asia. The world was not empty, and yet within roughly 50,000 years, Homo sapiens had reached Australia. They had crossed into the Americas. They had spread to the far corners of the globe. And everywhere they went, the other human species disappeared. Why? That's the question that haunts anthropologists. Was it violence, competition for resources? Did Homo sapiens simply outcompete the others? Better tools, better social organization, better language? Or was it something subtler? Disease, climate shifts, a gradual decline in numbers until the last Neanderthal or Denisovan simply had no one left to reproduce with. The honest answer is that we don't fully know. But what we do know is this: modern genetic analysis has shown that our ancestors didn't just replace the other species, they interbred with them. If you're of European or Asian descent, roughly 1 to 4% of your DNA is Neanderthal. Some populations in Southeast Asia carry Denisovan DNA. The story wasn't pure replacement. It was complex, messy, and deeply human. If you're finding this as fascinating as we do, make sure to subscribe. This is exactly the kind of deep dive content we create here, and there's a lot more coming. So now we have Homo sapiens, scattered across the globe, living in small bands of hunter-gatherers, following animal migrations, reading the seasons, surviving on sharp wits and social cohesion. And for tens of thousands of years, that was enough. But something was building. Something was about to change. Around 12,000 years ago, in a region that would later be called the Fertile Crescent, stretching across what is now the Middle East, humans began doing something they had never done before at scale. They started farming. This wasn't an overnight decision. It was a gradual process driven by climate shifts at the end of the last ice age, growing population pressure, and thousands of small experiments with seeds and soil. But the impact was seismic. Farming meant staying in one place. Staying in one place meant permanent settlements. Permanent settlements meant larger population. Larger populations meant new social problems, and eventually new social structures. The nomadic band, in which everyone was more or less equal and decisions were made communally, began to give way to something more complex, something with hierarchy, something with rules. And with farming came surplus. For the first time in human history, it was possible to produce more food than you immediately needed. That surplus could be stored, it could be traded, it could be taxed. And the moment surplus entered the equation, social inequality followed close behind. Because someone had to control the granary, someone had to decide who got water from the irrigation channels, someone had to settle disputes over land. That someone became the chief, the priest, the king. Here's a question worth sitting with. When did humans first start believing in something greater than themselves? The answer, based on the archaeological evidence, is much earlier than you might think. Sites like Göbekli Tepe in modern-day Turkey, dated to roughly 12,000 years ago, show massive stone pillars arranged in circles, carved with animals and abstract symbols, all built before the invention of pottery, before agriculture took hold, possibly by hunter-gatherers coordinating a project that would have required enormous social organization. We don't know exactly what it was for, but the leading interpretation is that it was a ritual site, a place of ceremony and belief. This tells us something profound: the human impulse to make meaning, to look up at the sky, feel something vast and unknown, and try to reach toward it. That impulse is ancient. It predates civilization as we know it. It might even have helped cause civilization, because shared belief is one of the most powerful tools for organizing large groups of people who don't personally know each other. You can't coordinate thousands of people with just kinship, but you can coordinate them with a shared story, a shared God, a shared cosmology. This is what the anthropologist Yuval Noah Harari calls cognitive fiction. The ability to believe in things that don't physically exist but are real in terms of their effect on human behavior. Gods, nations, laws, money, these are all things that exist because enough people agree that they exist. And that ability to create and share abstract belief is one of the most distinctly human traits we have. 40,000 years ago, while all of this social complexity was developing, something else was happening in the caves of Europe and Southeast Asia. People were making art. The cave paintings of Lascaux in France, dated to roughly 17,000 years ago, show horses, bison, deer, and aurochs rendered with astonishing skill and visual sophistication. The paintings in the Chauvet cave in France push even further back, roughly 36,000 years. And in the caves of Sulawesi, Indonesia, researchers have found hand stencils and animal figures that are at least 45,000 years old, among the oldest known figurative art on Earth. What does it mean that ancient humans were doing this? It means they had imagination. It means they could form a mental image of an animal they'd seen days ago and reproduce it on a stone wall. It means they were telling stories, not just with sounds, but with pictures. It means they were thinking about the past, about the future, about things that weren't immediately in front of them. That capacity and to hold an abstract concept in the mind and manipulate it is one of the defining features of human cognition. It's what allows us to plan, to invent, to lie, to cooperate, to build cathedrals and write symphonies and feel nostalgia and imagine better futures. And it was already there, fully formed, in the people who painted those caves. Let's talk about language, because it might be the most important development in the entire history of our species. We don't know exactly when humans developed full, complex language. The fossil record can tell us about bones and tools, but it can't directly record speech. What we can do is look at indirect evidence, the shape of the vocal tract, the structure of the brain, the complexity of behavior, and make educated inferences. The hyoid bone, which supports the tongue and is essential for complex speech, appears in Homo sapiens and was also present in Neanderthals, suggesting that Neanderthals may have been capable of some form of speech as well. But the full recursive grammar, the ability to embed clauses within clauses to talk about things that happened yesterday or will happen tomorrow, to discuss abstract concepts, that seems to be more uniquely human. Language transformed everything. Before language, knowledge died with the individual. After language, knowledge could be passed on. A grandmother could teach a grandchild how to find water in a drought, what plants were dangerous, which routes were safe. And once knowledge could accumulate across generations, not just through slow genetic change, but through rapid cultural transmission, human progress began to move at a completely different speed. This is what scientists call cumulative culture. Each generation doesn't start from scratch. It builds on what came before, and the primary vehicle for that accumulation is language. So where does this all leave us? Here's the shape of the story we've just walked through. 7 million years ago, a primate stood up. 2.5 million years ago, it started making tools. 2 million years ago, it left Africa for the first time. 300,000 years ago, our own species appeared. 70,000 years ago, the cognitive revolution, art, ritual, complex language, symbolic thought, lit a fuse that has never gone out. 12,000 years ago, agriculture began to reshape human society from the ground up. And from there, the path runs straight to cities, to writing, to empires, to science, to the world you're living in right now. But here's what I want you to take away from all of this. The human story isn't a story of steady, inevitable progress. It's a story of contingency, of accidents and close calls. Our lineage nearly went extinct multiple times. About 70,000 years ago, a massive volcanic eruption, the Toba catastrophe, may have reduced the entire human population to just a few thousand individuals. A handful of people, that's it. That's how close we came to not existing at all. And yet here we are, 8 billion of us, on every continent, reshaping the planet's surface, reaching into space, mapping our own genome, digging up the bones of our ancestors and asking them who we are and where we came from. That curiosity, that desperate, relentless, deeply human need to understand, is older than cities, older than farming. It's written into the same biology that made our ancestors walk out of Africa into an unknown world. It's the same impulse that drove someone 40,000 years ago to put their hand against a cave wall and blow red ochre through a hollow bone, leaving a print that says, "I was here, I existed, I mattered." And that impulse is still alive in you, right now. Listening to this story, the human origin story isn't finished. We're still in it. And the more we understand about where we came from, the more we can understand about where we're going. If you like this video, subscribe. We drop documentaries like this all the time. And leave a comment. Which part of human evolution do you find most mind-blowing? Because your answers shape what we make next.